In this tutorial I will explain how to find setups to get very precise positions in Majora's Mask and Ocarina of Time. And maybe this can also be used in other games, I don't know. And when I say very precise positions, then I mean float perfect positions. Positions that have zero leniency. The techniques I'm going to show you can also be used to find less precise positions. For example, I've used it for an itemless escape setup in Ocarina of Time in the past. But what I've been mostly using it for is light knot SRM in Majora's Mask. I have made a tool for this, Posefi, the position setup finder. It is not quite finished yet, and I don't know if I will ever finish it, but it has all the essential features that we need. And to show you how it is used, I will show you 3 examples. First, I will show you a setup where we just get a Z position for a Song of Soaring wrong warp in Majora's Mask. Then I will show you a light knot SRM setup in Observatory, where we will actually get a perfect Y and Z coordinate. And then last I will show you an example in Ocarina of Time where I used the held actor data, position data, for a light knot SRM. So let's get started. Alright, example number 1. In Majora's Mask, 2 of the most common SRM wrong warps are the Z copy warps and the LFZ warps. Both do basically the same thing. When you soar to the South Clocktown Owl, then the warp will take you to a location based on either the lowest or the 2 lowest bytes of your Z coordinates, depending on which version you set up with light knot SRM earlier. So in our example we have the second version where we warp to a location based on our 2 lowest bytes. For our example, we want to find a setup to warp from South Clocktown to the most important room in the game, Jabba's room in Zora Hall. We take a look at the Majora's Mask Ultimate spreadsheet, then under maps we can see that Zora Hall rooms has the scene ID 4C in hexadecimal, and under entrances we can see that Jabba's room has entrance ID number 1. So the position we need, the Z position, needs to end in 4C01. Well, for the scene value, the game also accepts the negative equivalent. So in the Windows calculator, you can go to developer and then switch to hexadecimal. I've already selected that here. And just type in -4C, and then you see the negative equivalent is B4. So the lower 2 bytes can also be B401. So the first thing we're gonna do here in Posefi is we're gonna choose the option find Z, since we do not need X. Also, if you ever want to directly search for a Y position, then you can change these here. This is just visuals. This just changes the letter. Usually you want to search for X and Z coordinate, even if you need a Y coordinate, because yeah, the Y coordinate indirectly corresponds to your Z and X position. So usually you should use this here. Then we have these options here, which we do not need yet. I will explain later what that does. And then yeah, we have the default position. We can ignore the X position. So we're just gonna type in our default Z position, which is C43 C1000. So next we have this section here where we type in the position we want to find. Yeah, we have 2 options. First we can type in a name if you want or not. It will auto-complete if you don't type anything here. So yeah, the grayed out stuff is for X. Since we don't want to find any X, we don't need this, we can ignore this. Then we have this column here where we type in the Z position we want, and we can just type in 4C01 and B401. These are the 2 options we have. And then we can type in some plus minus, which then still will be treated as a valid solution. So either if you expect some truncation error or if your setup has some leniency. And actually truncation error happens very often. It's very common. So most likely you want to type in something here, and then yeah, you need to test afterwards if your solution works or not. There is not really any way around that. But yeah, let's ignore this for now. We will see later what we can do with this. Then we have the AND operator, which is actually very important for our case here, because we want to ignore the higher 2 bytes. So we just gonna need 4 Fs at the end. We can also ignore these zeros here. We can just type F and it will autocomplete. Yeah. And then we have yeah, options for the maximum cost that we want to allow. We can set this to 50 for now. I don't know. We will see later. You can also type in either 0 or a negative number. So if I take 0, then the first solution that will be found, let's say we found a solution that has costs 40, then only afterwards solutions that have costs 40 or lower will be allowed. Or if I take -2 and we find solution 40, then only solutions that are 42 or lower will be allowed. So you also have these options. But yeah, I don't know, let's take 50 for now. And now we will actually start playing the game. So we have the actions section here where we can now type in our actions, and yeah, let's just start with the normal sword slash. I usually just call this normal, a normal sword slash. And then yeah, we type in the Z position we have right now, C4, 3, A, C, C, 9, 4. And then we're gonna type in the angle we have, and yeah, we can type the range in which we want to allow these slashes, and if you type in something negative, then this will be treated as a slash in the opposite direction. So if I do a slash in this direction, then this will be -1, except in this case I slashed a wall, so this will be not exactly the same. Be aware of that. What you can do in a situation like that is you do, for example, a roll here, slash, and then roll back, and this will probably be the same as the negative slash. So if I do a slash now, yeah, now we have our default position again. You can do something like that, but I don't think in this case it's worth it, so I'm just gonna type in 0 here and here. Let's say maximum 10 slashes and costs 2 or whatever, yeah. So this is the basic principle. Some more movement options we have in Majora's Mask are, for example, slashing while targeting, or slashing with the shield cancel, or slashing with target and then untarget during the slash, or slashing with control stick right or forward, and then also right and untarget during the slash and forward untarget during the slash. We have jump slash, and untarget during the slash. We have spin, and we have spin with shield cancel. And yeah, these are just some options. As human and yeah, as Zora and Goron, there are even more options. And yeah, you're gonna try out stuff. Yeah, I have typed in some options here. Maybe that's already sufficient or enough or not, we will see. Yeah, if you wonder which super duper advanced math this application might use, it is called brute force, and it's super complicated. It's going through every combination of these actions, and then it adds everything up and sees if it got the right position or not. Yeah, I know it's super complicated. Yeah, we're just gonna hit start, and yeah, it went through 2 million different combinations, and we actually found 11 solutions. And then we have yeah, sort option here, which you cannot see because OBS is stupid, and I'm using window capture, and this menu here is treated as a different window. But there's an option called sort by cost. You're gonna trust me, dude? Yeah, we're gonna sort by costs, and we actually have this here, cost 26, which by the way is actually awful, but we're gonna use this now. Yeah, we have 1 normal slash, then 5 targets. And then we have 1 with shield, 1 jump slash, 1 target and untarget, and then 6 slashes right. And we actually got B401 without any truncation error first try. That's actually pretty amazing. Nonetheless, yeah, this is an awful solution. You might want to search with different angles. Find maybe something that's like, I don't know, costs 10 or less. That would be an acceptable solution in my opinion. Little side note about floating point numbers and truncation errors. It usually happens when you cross the border to a new exponent. So if you take a look at how floating point numbers look in memory, then you can see the first bit is for the sign. So when it starts with 4, then it's positive, and with C it's negative. But the 4 bits that come after that are for the exponent. And yeah, I've written down some ranges of numbers that are all within one exponent, and then once you cross this border, then you reach a new exponent. So currently I have a setup here where I am in this range, but now I'm going to do shield slash, and now I am in this range here. So I crossed in exponent order, and now if I do the same movement back, then I actually have a tiny truncation error of 1 bit. And this can be very useful. What I did just here with this shield slash, this is actually very common in Majora's Mask. In Ocarina of Time there are different techniques, but yeah, this can be really useful for tiny adjustments. So let's move on to the observatory example, and I'm going to show you how I found a setup for LFZ warps that are based only on your lowest byte. Yeah, I found this setup quite recently. And yeah, the first thing we want to do is we want to see which X position we even need, because we need a specific Y and Z position for this, but as I said, it's usually not so good to look at your Y position. So yeah, what you're gonna do is you hack in everything to see which X position corresponds to the right Y position. So we go to debug, to actors, and to player, and then we can change here the Z position. So I'm gonna hack this to what it says on the left. So this would be the right Z position, and then yeah, I can already tell you that the right X position is about this here. Normally you would need to try a little bit to get this right, but yeah, I'm making this a little bit faster by just using my future knowledge. However, this is actually not quite the full story, because there's a range to it. And yeah, this is just what the final setup's position was. However, I can also change this a little bit, and you see the Y position does not change. So we actually do have a little bit of range here. And it's actually quite huge. So this is the higher end, so we have like 4, 2, 5, B, F, 3, 0, 6. And then the lower end would be this is too low. Okay, this is what we already had. This works. This does not work. So this is the lower end. 4, 2, 5, B, F2, F9. So now things are going to be a little bit more complicated, because yeah, we need to find X and Z position with one setup so that we end up with both coordinates correctly. And yeah, to demonstrate how that is done, of course, only works with a paint diagram. So let's say we have a top-down view here on the floor where we want to do our setup, and this red dot here is the position that we want to get. And we have a wall here that is perpendicular to the Z-axis, and we have another wall here that is not perpendicular to any axis, but yeah, it is good enough to get a corner here where we can get a consistent starting position. So let's say we get into this corner, And from there we do a backflip and a roll or side hop or whatever. So we can get from here to there and to this point here consistently. This is our consistent starting point. And what we're going to do next is we are going to search for a setup that gets us the right x coordinate. So we just want to go from here to anywhere on the red line. So let's say we found a setup and we can get from here to there consistently. And now obviously the z coordinate is still very much wrong. So what we're going to do next is, of course, we're searching a setup that gets us the right z coordinates. So we want to go from here to anywhere on this red line. And let's say we found this setup here to get from here to there. And yeah, now obviously the x coordinate is wrong again. And you might wonder, what the hell did this achieve? Well, there is actually one very simple thing that you can do now. If we now take a look at just the blue arrows for a second. So every blue arrow is a setup or part of a setup that we figured out. So we are still starting in this corner here and do our backflip here. And then our roll to here. So this is still pretty much our starting point. But then we change the order of the rest of the setup. So we are not actually doing this here next. Let's move this to this side for a moment. We're actually first doing this here, the second setup that we figured out. And from here, we're still not using this. We are actually just running into the wall to reset our x coordinate. So we are here now, and from there we are actually doing this backflip again. So now we are about here, and now we can do the first setup that we figured out, if I can find it here. So we are like this. Yeah, a little bit difficult to do this precisely in Paint, but yeah, you get the idea. So like this, you can figure out position setups for the z coordinate and the x coordinate separately and still combine them in the end. And yeah, this is how you get load perfect positions. So the big disadvantage of this setup is, of course, that you need a perpendicular wall, and I don't know of any technique on how to get float perfect position setups on two coordinates at the same time without a perpendicular wall. Except maybe if you have a non-perpendicular wall, you can rotate the entire coordinate system, so basically simulating a perpendicular wall. So you can then use this technique. However, you first have to rotate it to get the perpendicular wall, which will already cause a lot of truncation error, most likely. And then in the end, you have to rotate everything back, and that will cause even more truncation error, probably. So I highly doubt that this would work out, but hey, if anybody would like to try this, that would be really interesting. So in this example, we will have our z position that can be reset. So yeah, this wall, we walk into it, we get the same position again. Yeah, normally you would maybe set this here. However, this only is relevant if we would do a combined search where we search for z and x all together, but this would only be possible with this section here that I have not started working on at all yet. So if one day I complete this, then yeah, you would need to set this here, but since we are only searching for z in this example, you can just ignore this, because the application also ignores it unless you have find both set. But yeah, with this and this, it will just always ignore it, so we can as well. In our next example, in Ocarina of Time, we will actually have two walls, so we can reset both x and z, and then we actually need to set both of these. But yeah, for now, it doesn't matter. So the data I have set up here, I actually loaded from a file, so yeah, I have a menu here, which of course you cannot see because, again, OBS thinks it's a different window. But yeah, there's a save input data and load input data option where you can load and save everything that you can see here, and you can also load input data from two different files. However, only do this if the default position is the same in both of these files. Otherwise, this will not make any sense at all. Yeah, be warned. Maybe just don't do that. Now for this setup, it turned out to be actually quite difficult to find a good position. So I actually also have quite unusual movement options like target spin, which would be target slash and then a spin. And I have this stab left, where you, when you are close to the wall, hold all the way left and then stab. Yeah, if you run out of options, then maybe you can consider something like that. Then we have also scoots, which is, yeah, just doing this. And then I have something that I call the smallest possible adjustment. I haven't even listed this because honestly, if you need this, then your setup is not good. But sometimes there are setups that are so hard to find where you might need this. So if you walk 2 frames forward and 2 frames backwards, then this is what I call the smallest possible adjustment. And if you see the lowest digits of the Z position are still the same. So this is why I call it an adjustment, because it will only change the higher bytes, and I should recalibrate my controller maybe. So if we have something like the smallest adjustment or scoots, for example, scoots also tend to only change the higher bytes, then yeah, what you can do is, if you have a lot of options, which we actually have right now, then you can reduce these options by simply assuming that, yeah, it's good enough to find the lowest 4 digits, because, yeah, we can probably adjust with scoots anyway, but this does not actually always work. So with scoots, you can see I could not get a value C3A12400, for example, because it skips over it. Yeah. If your search becomes too long, then you can consider something like that, and then you will get probably a lot of false solutions, but yeah, it can maybe speed up the process. So now I'm gonna show what I actually did and what we found here, so and what even the starting position is. I didn't show that at all yet. So we roll into this corner. Yeah, the X position can end in F2 or F1. In this case, I already can tell you that it doesn't matter, but sometimes it matters, so just keep track of which you got. You can actually control this by yeah, holding into this corner and then doing a full side hop. And then you always get F1, and I think if you do this, you get F2 or something like that, yeah. Yeah, so you just need to keep track of what you actually started with, and then it can actually sometimes be good for tiny adjustments of the X position. So first we are going to do this step left, except we are not actually doing it in this corner, because if I remember correctly, it gives you a slightly different Z position than if you do it up here. And when I measured which Z position it gives you, I did it up here, so yeah, we're gonna start here. Another interesting thing about this setup is that we have Gilded Sword, and with Gilded Sword we are much more likely to hit this railing or the wall if we face the other way, or if we stand more left or right, depending on all these factors. We may or may not hit railing or wall. Of course, with Kokiri Sword you can also hit the wall or the railing, and it can make a difference for the later parts where we need to find the X position, because at the end of this setup, at the end of these actions here, then we will have an X position from where we search the X position that we need. And yeah, you can actually maybe switch the order of things to get different default positions, and yeah, that can again give you more options. Sometimes also the default X position that you end up with might not be good or favorable. Yeah, you just need to keep track of what you did to get the X position again consistently. So let's for now just do everything in the order that this here tells us, except step left, because we already did that. Yeah, let's just do 7 slashes targeted. And then we turn around and do 1 normal slash, and you can actually see my angle now is not 4000 but 4001. Tiny differences like that usually don't make a difference, so you don't really need to be worried about that. So we do normal slash here, and yeah, we turn around again and do a forward slash, and this is obviously a bad order since we can just do this forward slash before the normal slash with the in the other direction. Then we have 4 scoots to the left, and I can already tell you this is actually the same as stabbing the wall and doing 1 step to the right. So 1 step is the equivalent of 3 scoots. So whatever, I'm gonna do what the solution tells us. So we now have target plus spin, and I actually forgot to write down that it actually also needs to be shielded. So yeah, this is the right solution. C3A01C54. So I have my file open here that I used for finding the X position, and you can already see here my default X position is not quite what we found. And yeah, I'm gonna show you the order in which I did things to end up with that position. So I only do 1 roll upstairs there and do this step here. Do forward and then the spin. The 7 slashes here, stabbing the wall, doing 1 scoot. And now the key difference is that you actually hit the railing instead of the wall, and that gives you quite a different position. And I guess, yeah, so I have X position ending in F now because my position in the corner ended in F2. If you start with F1, then you get this B here. I actually have listed something interesting here in my actions. That is a different default position. If you do things in the order that you hit the wall instead of the railing, then this here is the default position you end up with. And yeah, if you midway think, hey, I actually wanted to have a different default position, but I already measured all my actions here, what you can do is, yeah, just type this in and then you give it action minimum 1 and maximum 1, so this will then always be applied. However, in this case I actually gave it 0 and 1 because I wanted to test both these options, because we have both default position options. But yeah, if you during a setup change your mind, you want to do something else, to start with a different default position, then you do not actually have to measure everything again. Not necessarily. Again, this might make truncation errors differently if you start from a very different position, but in this case both default positions still have the same exponents, so it should be fine. So yeah, let's just hit start, and this takes a little bit longer than the last time. The range I have determined here is not 100% the range that we had figured out earlier. If I remember correctly, during my testing, turned out to, yeah, behave a little bit differently with truncation stuff and everything, that I shifted the position that I wanted to find a little bit. And then we also have the corner where we can get different starting positions and stuff. So yeah, I honestly don't quite remember what my thought process was here, but yeah. If you realize during your setup that you keep getting slightly different outcomes in a certain direction, then you can maybe just adjust your position that you want to find a little bit, so yeah, that you might end up finding the right position. Alright, so this is the solution I found with the lowest costs, and this is also what I ended up with. So yeah, let's just do this. Again, this has those steps that we need to start with. 2 steps left, and yeah, after that let's do it in order that this says. We have target slash here. By the way, for this one it really doesn't matter if we hit walls or anything. Then jump slash this way forward. And then we have a roll downstairs. And a scoot upwards. And this is indeed in the range that we wanted. So now again, the Z position is now wrong, but our X and Y position is now right. So yeah, we just need to change the order a little bit. Alright, so we have everything we need now to do the full setup. So we get into the corner and we face upstairs, do a roll. And now we want to get to the railing, but we cannot actually face this way with a straight angle. So we need to target the wall here and then we can backwalk to the railing and yeah, turn around. And now do those 2 steps. And we can actually spam those here. This will in this case not make a difference. So we have then 2 steps forward and a jump slash, or the other way around. I guess I changed the order right now. Yeah, turn around, do this target slash, and now we run into the wall to reset our Z position. And we do the 1 step left here, face upstairs, and now the order is 1 forward, target, spin shield, the 7 target slashes. And now I actually put the scoot here. The scoot technically belongs to the X position setup, but yeah, it makes much more sense to put it here because we don't need to change angle since we already have C000. And we step the wall and do 1 more scoot here and face downwards, 1 normal slash, put away sword, 1 roll, and boom, that's our final position. So we are now in Ocarina of Time and we are in Lost Woods, and we will be working with the held actor data. That's the one you see on the right. Currently that's not moving because I'm not holding anything, but as soon as I pull out a bomb, you see it actually keeps fluctuating even if you don't move. So yeah, that's obviously because Link keeps breathing and moving very slightly, but yeah, you can, if you do the same action, like just putting it on the bomb here, you can consistently get the same outcomes. Or what you can do is instantly dropping a bomb, or dropping a bomb after exactly 3 frames or whatever, but yeah, that's, of course, you would need to buffer that. So yeah, instantly dropping a bomb is what I ended up using for my ironic boots setup over here. So if I instantly drop the bomb here, then the data on the right is what we would need for the ironic boots. So our goal position is all the way over here. However, we want to do the setup over there because the corners are here and we have the perpendicular walls to reset our coordinates. We could also do it in this corner, but there's Mido here, so this corner is probably better. And yeah, for testing it's kind of stupid if you do your setup and then you would need to go all the way over here or do some generic movement over here to test if you actually got the right position. So what we want to do is we actually first do some generic movement over there that we can then later just do back. And then yeah, later we can test with this new position that we now move to here. So this, for example, this can be our new goal position. And right after you got your new default position, you want to do the same movements backwards just to see if you can actually still get it. I did rolls here because there's the slope, and side hopping down or up a slope is of course not exactly the same. But yeah, rolling should be consistent, and maybe we can actually use side hops. We need to see afterwards if that's also an option. Why is the camera actually always trying to move behind Link? This is so stupid. Why is the camera doing this?
Camera in this game is kind of stupid sometimes. Unlike Majora's Mask camera, which is always perfect.
Anyway, we actually got our old position back, so this works. So now we can test if side hops might actually work. So if we now look at the lower digits of X and Z, then we can see they do actually not change. So this is a good indicator for this maybe working. Let's see if we cannot do another side up. We will crash into the wall. So this looks decent. Yeah, this is already correct on the X position. And for the Z position, we can do 2 scoots, and now we got our position. So we're back in Posefi now, and I have already set up quite some data here. And I did a little bit of an oopsie because I accidentally put the goal position as the default position, which is of course not correct. The default position should rather be this here. But it is fine because I could fix it by simply putting an extra action for the default. So this is the default position, and then I again put minimum and maximum to 1. So it will always apply this in every iteration. So in the end, the math should still be correct. And I could not just edit the default position here because all this inserted data here relies on this default position. If I just changed this, but not the data over here, then the math would all be wrong. So as I said earlier, we can reset X and Z here. So we are going to search for both. And we have an interesting action here in Ocarina of Time, which is a slash where you target and hold right. And this will, depending on your angle, sometimes very slightly adjust your position, or maybe sometimes also do nothing at all. So this is with angle 1 or angle 0. And if I turn around, this actually goes the opposite direction also. If I do it with this angle here, angle 4000, nothing happens. And there's also nothing the other direction. That was the wrong slash. Anyway, you can trust me, dude. Or with yet another angle here, also nothing happens. But I got it earlier where it actually, where it decreases here, for example, the X and increases the Z. So this is actually really good for slight adjustments, and we can use this later. And we could include this as actions immediately here, but yeah, it will increase the search time. So what I did instead is I just put some lenience here in the searched columns. I've also included scoots here for later adjustments, and I put it in the range -3 to 4 because one roll, which we have also included here, is the same distance as 8 scoots. So instead of 5 scoots, for example, we could do one roll and then 3 scoots backwards. So this way we can just minimize the count of actions here. So this will reduce the time of the search. So let's just hit start and see what happens. And yeah, this will take quite some while, too long if you ask me. So what we are going to do is we will reduce the roll counts here. 3 rolls are probably way too much anyway. 2 rolls are probably still too much, but we will see. Yeah, so this already looks quite a bit better. Yeah, we are this time not instantly finding something, and I think this might be because our default position is a little bit far away from our goal position. So at first the application will apply all these sort actions here, and those don't really move us very fast. So later when the roll actions are applied, then we will move closer to the goal position. But yeah, we can reduce this process by simply adjusting our default position. Since we already have this set up here anyway, it will not even be an extra action. So let's restart this, and we are actually finding something instantly. Nice. It looks like we don't really need rolls at all for now. And also I found a typo here on my scoots, and I kept getting wrong solutions that all were around this X position here. So 44C2 3146, and it were a lot of different solutions also that all gave me this wrong solution, and they also all included one scoot. So if you keep getting wrong solutions and consistently always the same wrong solution, then you most likely have a typo. Yeah, all the solutions we found here are of course 3, and that might suggest that they are all about equally good. But that's probably not the case. I have some more sort options here that, of course, again, you cannot see. But I have, for example, a sort by cost of unique angles. So that we, for example, only face one direction the entire time and do all the actions in one direction. So that would, of course, reduce some turning around time. Yeah, unfortunately, it's a little bit dumb with the default position, since that has default angle 0, so in this case, if you use this technique, then this will kind of interfere with this, unfortunately. But yeah, usually that can be used to get you better solutions. Another sort option I have is sort by count of unique actions. That is basically just so you don't need to remember too many different actions, so easier to remember. So let's just try out what this here tells us. We do a target slash, turn around, and then we do a normal and shields, cancel slash. And this doesn't give us exactly what it says here. So this is not exactly what we want. We can of course use this adjustment technique here, but that would be an extra slash. And yeah, if we can avoid it, that would be good. We have yeah, the same solution basically again with just a scoot. Because yeah, scoots in this direction don't change X, so be gone. And this again, this is just the scoot in the opposite direction, and this is with 2 scoots, and this is probably 2 scoots in the different in the other direction, 3 scoots, and yeah, this will repeat it a little bit. Should have taken out the scoots, but yeah, if you don't know which position you are going to find yet, if it's X or Z, then yeah, you cannot take out these. Yeah, this is a different one here. We are targeting, turning this way, and doing target again, and turn down, and shield, and this looks good. Yeah, I think we can take this one. Yeah, all the other solutions also turned out to just be the same with scoots again. So yeah, what we are going to do now is we want a new default position, default Z, let's call it like that, and now we can switch to find Z only. So our new Z default position here is C42538F6. And set it to 1 here, plus 0. Let's see what happens. I didn't actually find anything right away with the configuration I had, so I had to add some more actions. So I added side roll right and left, which I measured by jumping back and forth so that the side hop distance is not actually included, only the roll. So yeah, I found quite some stuff. This was our default position after the first part. Yeah, so I did already sort this here by cost, so let's see what we have here. I think we have something quite decent here. Yeah, I just gonna start with the angle I already have. So let's do side rolls left, and then with the other angle 1 right. We have 1 scoot, and we have 3 sheep cancel slashes. And then with 4001 target, and that checks out. And now we can do the entire thing. So let's at our starting position here, and we start with the Z position part, and we have yeah, let's just do it in order for now. We can later maybe see what the optimal order would be. And that's 1 scoot. Yeah, this scoot is probably actually pretty dumb to do, since later we will do the scoots in the opposite direction. But yeah, maybe it changes something about side hopping on the slopes. So yeah, for now we are just going to do it. So we have this side roll right, 2 side rolls left, and yeah, we might actually crash into the wall here, but that would be fine. Yeah, we did, but it's fine because we would need to reset our X position now anyway, so that actually is favorable. So now side hop left, right again, so we have our default X position. And yeah, since we already have this angle, we do a shield slash cancel. Target this way and target this way. And that is our goal position indeed, except it's slightly different. So we can, yeah, this looks good. A roll here and a roll there. So we already checked that we can get from here to our actual goal position earlier. So Yeah, let's do this one scoot backwards so we can see if without that scoot we can actually still get there. And we have again some adjustment to do here, and yeah, indeed, we just need one scoot. Neat. I think that's everything I have to say about how finding those precise positions work and how using Posefi works. If I forgot anything to explain or if something was unclear, you can ask me in Discord. Or if you find a bug in Posefi, you can also tell me. I really hope it's user-friendly, because that really was my goal with this application. Well, my main goal was to learn the framework Qt. This was the main reason why I even started working on this application. So this is basically my practice project. And that's also how the code looks like. This is really... It's just a bunch of beginner spaghetti code. Please don't look at it. The only reason I published it is because I'm legally required to publish it. And because of TOS reasons. Yeah, just don't look at the code.